Kinematics and dynamics of particles. Okay, let's start from chapter 2. Mechanics is the study of physics of motion and how it relates to the physical factors that affect them, like force, mass, momentum, and ints. Can be divided into two. In case of kinematics, the difference between kinematics and dynamics. Kinematics deals about motion without considering its cause, but the dynamics consider the cause of motion. Dynamics and kinematics, so which deals with the motion of object. Dynamics with its cause. We consider force, like the equation of force is equal to mass times acceleration. Kinematics describe the possible motion of a body or system of bodies without considering the cause, without considering force. So in most cases the cause is force. So the study of properties of motion, these kinematics include position, velocity, acceleration, instantaneous velocity, instantaneous acceleration, blah blah, will be included under the kinematics. For example, we have two problems here. First problem is this one, the second problem is this one. So we have to categorize them under dynamics and kinematics. For the first one, it said a car starts from rest and accelerate at 4 meters per second square. How long does it take to cover 100 meters are classified under kinematics, because these values for this question, car starts from the initial velocity 0. There is also acceleration, and it says how long does it take to cover this much meter. There is a meter distance is already given, which is 100 meters. So the time is the question. So there is no including of the cause, there is no including of force, blah blah. So this is under kinematics, included under kinematics. Whereas the second one, it says 100 gram mass is attached to a spring with a spring constant, it's given, which is the unit is Newton per meter. So this is a spring constant value, hangs vertically from a support. How much does the spring stretch? Are classified under dynamics, because whenever we deal about this, we have to consider the force, we have to consider mass attached to the spring, which is this one is a mass, and this is k value. So whenever we look for the x value, so that you should apply the Hooke's law. Force is equal to force restoring force is minus kx, so we should include the force, the cause. Therefore, in such cases, we need to calculate regarding the change in x value. So this is under the category of dynamics. Okay, now let's look the 2.11. Sorry, displacement, velocity, acceleration in 1D and 2D. So definition of kinematical quantity. The first one is position. So the location of an object with respect to its chosen reference point is called the position. Chosen with a reference point is the position. So this xi is initial position. This is x final is the final position. So it's possible to get change in x value, which is x final minus x initial. This is only for the case of one-dimensional motion, consideration of one-dimensional motion. So displacement is the change in position of an object with respect to a given reference frame. So the displacement is just the x final minus initial is the value of the displacement. So we apply such formula for the case of one-dimensional motion. If a person starts from this point, let's say this is point A, and goes to point, let's say this is point B, goes to point B and return back to point A, in such cases the displacement value is 0, because x final and x initial are the same. Therefore, in such cases, x final minus x initial is the same as x final. So the value of change in x, which is the displacement, will be equal to 0 if the person return back to its original position. Okay. Now let's go to an example for two-dimensional motion. Consider this is an x-axis and this one is the y-axis. So the motion is has a component in x and y, so it's considered to be a two-dimensional motion. This is the path of the motion. this one is the path of the motion. So starts from this position and goes to this position, and this position is given by r initial, and this one is given by r final. So this is r initial, by the way. R final is here. This is the point of r final. Therefore, change in r is the r final position from this one and to the initial position from this reference frame. So final minus initial is change in r value in case of two-dimensional motion. So distance is the length of the path followed by the object. Distance is the length of the path followed by the object. So having this in mind, now let's go to the average and instantaneous velocities. Average velocity is the total displacement divided by total time. Average velocity is the total displacement divided by the total time. The total displacement is r final minus r initial, and total time is t final minus t initial. So this is how we get the average velocity. This is how we get the average velocity. Okay, so average speed is the total distance traveled by the object divided by total elapsed time is for average speed. We need to find first the total distance, then the total interval of time. Then with that, it's possible to get the average speed. So this will be more elaborated when we solve different questions. So average speed and average velocity of an object do not provide detailed information of the entire motion. We may need to know the velocity or speed of the particle at a certain